So anyway, by doing we are measuring now how your glucose markers, if you will, insulin, something called incretin, which is a very interesting hormone. It's the one that everybody's using for these GLP agonists you may have heard for weight loss
Oh,
and
okay. Uh-huh.
diabetes control. We can measure all that right out of this little drop of blood. So we think it's really powerful for trying to see very specific, what's going on with your glucose control molecules, also inflammation molecules, things like that. So we think these targeted assays are quite powerful in addition to these broad-based assays.
Yeah, and so what's great about what you do is it's longitudinal over time.
That's
And this
correct.
microsampling is making it easier on the person, I guess, the subject. So
Yeah.
yeah, let's get into that. I mean, how might startups make this happen? Obviously Theranos was corrupt for various reasons, but how might a startup kind of bring this out?
Yeah, well, I think this is because it's a wellness kind of assay. It doesn't conform into the standard medical thing, so people have to pay out of pocket. So what we hope to do is so we started a company, and then you pay, I think it's, 270 bucks, something like that. And we give you, and you do the prick. Well, in this case, it's a shoulder collection, but same kind of idea, a very small microsample that you mail in, and that company measures over 500 analytes and gives you back a report. And they're markers for various things like kidney function, liver, even some mental health markers are in there as well. And then we give you back, here's what looks like is going on for your so-called wellness profile. And
Oh,
yeah, and the nice thing is you can follow it over time. So you can see how things shift, so you can change your habits. And people have done that based on things that are somewhat they're out of the normal range, so to speak, or they might not be as optimal as they could be compared to others. So people have adjusted their lifestyle, and actually we've seen improvements as a consequence of this. So that is the idea. It's to make it simple, make it easy for people to do. Right now, it's not an FDA approved test. It's run as a wellness assay, but the hope is that it will help people and we will show utility. And then, as we continue to roll it out, I do hope it'll become standard, much like measure yourself for all kinds of useful things now.
okay. So you anticipate it could be FDA approved. So this company you've set up is that would be direct to consumer model, right?
It is.
It's like a really glorified 23andMe.
It is. We think it's better than 23andMe because it's metabolite information, which is more actionable.
It's so much
You're,
more information. Yeah,
it
and
is, yeah,
longitudinally, right?
it is correct. So you can take action, you can see how things shift. 23andMe is great, by the way, but it's making polygenic risk scores. You get it once, you kind of get these scores, and it does work if you're at the top end of the distribution. If you're extremely high risk, the polygenic risk scores work. These are scores, genetic scores, for those who don't know, for complex disease, and they work in a subset of cases. This is much more actionable information. As I say, we don't measure glucose specifically. You should get that from your doctor, but we measure things that are related to insulin resistance, for example, so we can see roughly what's going on. People can make adjustments, and we would certainly, if you think something's really off, obviously you should go see your physician for follow-up tests. But bottom line is, it gives a ton of wellness information. The analogy I like to use is that, right now when you visit a physician's office, you get a very limited number of measurements, and some of them aren't even that useful. Like your heart rate in a physician's office, so for most people, it's super elevated. But we think that if you can do these measurements at home, you're going to get much more reliable measurements, and they'll be more reflective of what's going on. So we like the idea, and then by doing, say 600 measurements, we think that gives a clearer picture of your health than just taking 5 or 6 like you get in a physician's office. So it's like a jigsaw puzzle. You get a clearer picture if you have most of the pieces filled in.
Are you giving a bit of a report that helps just the average person kind of understand if they're out of the norm and what they might do about it?
Yeah, we do. In fact, we have kind of two versions of the report. A lot of physicians have gotten interested in this, and have and so we have been partnering with some of them, and there's a physicians-based one, which, they have obviously a medical background, and the information comes in a form that they are better poised to use, and then some is direct to consumer. So yeah, they're basically geared to whoever is looking at the report.
Oh, that's cool. Okay, so yeah, let's talk about the physician. Um, treating people based on averages, which we mentioned earlier, this one size fits all medicine is kind of what you want to get away from. And
It's a disaster.
it's
Yeah.
terrible for individuals. You talk about all the different responses to drinking this standard shake. And
Yep.
yeah, I for one, if I had a protein shake, I would like to know what's going on. So that's interesting. But this one size fits all has been pretty good for doctors in that, they can go get trained, and then there's just standard protocols. And your approach is different. Do you have to convince the doctors out there of a new kind of attitude?
Oh, for sure. Right now, I'm sure they're all scratching their head on this and wondering what this is all about. We've been through this odyssey before. So when we started sequencing healthy people's genomes,
That's true.
physicians 100% of the time said that is really a terrible thing to do. You're going to turn everybody into hypochondriacs. It's going to cost millions of dollars, scare everybody, and that of course never played out. People do want to learn about their genome. They have discovered important things. I wouldn't say all physicians are now on board with that, but they're a lot more warmer to it than they were. Then along came wearables, and here we are pushing, wearables for health monitoring, and
And doctors have learned how to receive
well,
data from their patients in that.
yeah, they initially pushed back hard on that, saying, look, everybody knows those aren't very accurate. We can show them more accurate than what you measure in a doctor's office, at least for resting heart rate, by a lot. It's not even close. So they're much better devices. So some are warming up to this. Some are still very, very resistant because part of it's the nature of the medical profession. They have 15 minutes to spend with you in a physician's office, and that's just not enough time to assess your health. And they don't have time to go back and look at previous measurements. So there's no automatic algorithms to say, look, here's your trajectory. Something's going off. They don't look at that. They just see whether you're in the normal range or not, make a decision and move on. And again, it's the nature of the system. But I think the power of pulling in this longitudinal data, as you know, is you can see trajectories, and you can really see whether something's going off. And we had someone in our study, we're studying probably now a little over 100 people now for over 10 years. And we see one of my favorites, case where someone had a liver enzyme, was in the normal range, always at the low end, and suddenly it doubled, but was still in the normal range. And nobody said a word to him. But he came to me and said, Mike, what's going on here? My liver enzyme just doubled. And I said, well, go get another measurement. That doesn't sound too good to me. So he didn't, and it went out of the normal range. But see, nobody caught it because it was still in the normal range, so it didn't matter. But all you had to do was look at his trajectory. You knew something was off, and then he took some corrective actions. It's all good. But had he not, spotted this himself, nobody would have noticed it in today's healthcare system for 2 years down the road. And who knows what it would have been like by then.
Okay.
So I think these trajectories are just absolutely critical, and we need to have them automated and put into our health monitoring.
Yeah, that's very cool. And just that story, I was thinking about myself. I mean, I go to the doctor once a year on good years, and have my checkup. But labs
probably not at all during the pandemic, right? Very few people did. Yeah.
No, I skipped a bit. Yeah.
Yeah.
Okay, so that's when measuring at home could have been really helpful.
Yeah.
And so, I do the labs and all the screening tests.
Okay.
And what you're saying is this just isn't covering it.
No. And also the question is once a year enough? The answer is it might be when you're younger, but I'll bet as you get older, you want to increase the frequency. Now, what the right frequency is, I think, is going to depend on what your disease risk is and what your trajectories look like. Mm-hmm. So I think it's going to get personalized in the future. Right now, we just do, when you're over 50, get a colonoscopy every N years. They just follow formulas, which, and that's just how the system works. But I think if we were really plotting trajectories properly, we could say, well, you should go a little more often. Some of your heart markers are not so good. Let's get your heart checked out a lot more, maybe get more stress echoes, that kind of thing than you would normally do. So I think we need to be following people again longitudinally, and I hope these biochemical, what we like are the biochemical tests would be good surrogate markers for a lot of health states, and same with the wearables with the physiological markers. I think they're just going to be super powerful for catching things early, and they may not be final diagnostics. I don't think they will be, but they may catch things going off, much like your check engine light on your car. So something's up, go get, dive in a little deeper, see what's going on.
Yeah. So you mentioned a company you got going already. What's the name of that company?
Yeah, that one's iollo, iollo. And so they'll measure over 500
iollo.
analytes.
iollo.
Yeah.
Okay.
Yeah.
So do you think that it will be businesses, it will be startups that will basically translate this into healthcare, into the healthcare system?
I hope so. Yeah, that's the goal.
Uh-huh. Oh, okay.
I think it's just
Like
easier
genetic testing, right? We had all these genetic testing companies which basically went out there and kind of pushed for getting payers. They pushed for training doctors. It's been these companies who have sort of implemented genomic medicine.
I think so. And it's two reasons for this. Again, our systems aren't properly set up with financial incentives in the right direction, meaning
So true.
nobody pays to keep you healthy. They really only get paid when you're sick. So right now, people are paying out of pocket. So forming startups where people pay is the way to get it going, to show that this stuff works. Much like Grail, you may know they have a cancer test. So that one's pretty
Early
expensive.
cancer detection.
Early cancer detection. And same thing, people have to pay out of pocket for a test to see, while they're healthy, because nobody's going to reimburse it. I think as time goes on down the road, when we can show the stuff has utility, it is cost effective, especially, I think that will really help a lot, actually, for driving this. So, but we need to show that, and it'll just take time.